We're here talking with Daniel Russer. Daniel is a senior researcher at Bioforsk and is leading the terrestrial carbon group. Daniel, can you tell us what biochar is?
Well, biochar is warmed heated biomass. We call it pyrolyzed, and pyrolyzed biomass is the heating of biomass without oxygen. So in this case you see this biomass come from the plant. Actually it's a tropical plant, miscanthus. I will explain this later why we've chosen this plant as special property for our research, and compared to this same plant material that has been pyrolyzed. It is now black. It's like charcoal basically.
Okay. What is the aim of this experiment that you have down here?
The aim of this experiment is the aim of developing biochar technology in Norway. And the first aim is to test for carbon sequestration and reduce greenhouse gas emission in Norwegian agriculture. So here we are going to test for the stability of this product, this biochar product, in the soil. Because what we know from many years of research is that untreated residues that contain a lot of carbon, the carbon goes right back to the atmosphere within a few years as CO2 and contributes to the greenhouse effect. While when it is pyrolyzed, this biochar is becoming stable in the soil and the carbon is being stored. And what we want to determine is for how long time it is being stored in the soil.
Is this sort of research going on all over the world?
Yes, at present there is a big interest in biochar, both for the carbon sequestration, the reduction of the greenhouse gas emission from agriculture, but also for the agricultural benefits of the biochar. I think many places have shown that it actually improves yield and water content of soils.
Okay, and I noticed that it's a type of loamy clay here. How relevant do you think biochar will be for Norwegian soils and Norway in general?
Well, I think as a carbon sequestration measure, it could work in any Norwegian soil. Now, if we are looking at the agricultural benefits, we expect that the benefits will probably be greater in sandy soils and in nutrient-poor soils. For this reason, actually, biochar might have its greatest potential in agronomy, in agriculture, in the tropics. But certainly this kind of technology is to be tested first in countries like Norway, where we have the possibility to do this field experiment, do them in detail, and have access to this first sets of pyrolyzed biomass to try for the potential. But it has great potential in poor soils, and it has been shown to increase yield in tropical poor soils.
Can you tell us about some of your other biochar projects going on at Bioforsk?
Well, we have a fundamental research project from the Research Council of Norway, and that one is really looking at the structure of the biochar, the molecular structure of the biochar. What we want to understand is not enough to understand, okay, this biochar is going to be stored for a long time in the field, and it's going to be a carbon sequestration measure. This is what we are doing. But there are many types of biochar. The different feedstock in Norway, we might want to produce it from tree residues, from straw, for example. That's an excellent material to produce biochar in Norway. But what we know is that the property of the biochar is going to be dependent on the feedstock. For this reason, we need a way to analyze molecular characterization of the biochar, to analyze the properties of the biochar, so that we can infer the sequestration time, the time the carbon is going to stay in the ground, and the benefits, and also the agricultural benefits of the biochar from this analysis. So we are working on this advanced method that we can characterize the biochar to predict its behavior in the field, like we are doing in this experiment.
Do you envisage in the future that one day farmers will be paid for carbon sequestration?
Well, I hope so. I think it will happen, because if you look at the potential for carbon sequestration and the total carbon being right now sequestered and stored in soil, it's very large, even as compared to emissions. Soils in the world store about 2,500 gigatons of carbon, and the total in the atmosphere is about 700 gigatons. So you see a factor of 3-4 times as much carbon in the soil, and if we can store just even a little bit more in the soil, this can have a dramatic effect on the greenhouse gas concentration in the atmosphere.
Thanks very much, Daniel.
You're welcome.
And good luck with your projects.
Thank you.